This is Physics 2212 Lab 2 going over lines of charge. Now in this lab we're going to be piggybacking off of Lab 1 and we're going to be observing the interactions between two pieces of clear tape with each other as seen here on the picture on the right where there's repulsion between the two tapes, and then we're going to be comparing models of point charges versus lines of charge, and we do this by creating multiple point charges along a line. Now, preview of the results, we get the charge of each tape is equal to about 2.61 e to the negative 8 coulombs, a magnitude of the electric force being about 1.75 e to the negative 3 newtons, and the magnitude of the gravitational force being about 1.96 e to the negative 3 newtons. Now, assumptions to get out of the way, air resistance first is going to be ignored, and then each tape is also going to have the same charge and it's going to be evenly distributed along the length of the tape. And then sources of potential error is going to be inaccurate measurements, and these measurements are just reused from Lab 1, and then inconsistent replication of the procedure. Now, the main formula we're going to be using is right here, derived from lecture, where K is going to be 9 e to the 9 Newton meter squared per Coulomb squared, and R is going to be equal to the distance between the tapes, and then L is going to be the length of the tape. And then assuming that the electric force is going to be equal to mg, which is the opposite of gravity, given that we're assuming we're in equilibrium, and we're going to have equal charges so that of the two tapes, we can actually solve for Q plugging in the electric force mg to find what the charge of the tape is going to be. Now, the results, the length of the tape in Lab 1 was 0.2 meters with a mass of 0.0002 kilograms, given that clear tape is about 1 gram per meter. The distance between the two tapes was 0.03 meters, and plugging everything into the equation for Q that we've just found, we get that the charge on each tape is equal to about 2.61 e to the negative 8 coulombs. Now, getting into the computational model, these are just constants and measurements taken from Lab 1 and just known quantities. And then right here at Q, we take that equation before and pretty much just put it into code, estimating the net charge on one tape. And then we actually have a function down here for the electric field. And then we have a function that creates a line of charge over so many points in. And in this situation, n is going to be uniform point charges with a given total charge and mass at equal intervals along the length of the tape, and then we set in later on. And this is just a visualization of the top tape and the bottom tape, where we set in equal to 100, so that's just how many points per tape along the whole length of the tape. Now, what's going on here is we pretty much use superposition to find a net field on the top tape due to the bottom tape, and we calculate the electric force on this top tape by adding up all the forces from each dq in the bottom tape when they interact with the dq in the top tape, as seen below, and then we just create some visualization with an arrow for the net electric field. Now, here is just more visualization for arrows for the electric force vector and then the gravitational force vector, and then just some printing statements to get the data out. This is what the final visualization looks like. We have a charge of 2.61 e to the negative 8th, and then we have our magnitude of the electric and gravitational forces. Now, this is definitely more accurate than using point charges, as we could see before that the force of gravity and the electric force are more similar than they were in Lab 1, and we get even more accurate results if we added more points and segments in the model, so if we took in from 100 up to, like, say, 200. And then remembering the sources of error that affect accuracy, such as assuming that each tape has the same charge and it's evenly distributed. Now, what if each tape was modeled as a single point charge? As you can see here, with a point charge of 1.4 e to the negative 8 coulombs, as calculated in Lab 1, we get that the magnitude of the electric force and the gravitational force are very, very different, with the gravitational force severely outweighing that of the electric force. As you can see, the magnitudes down here are drastically different, and you can see that visually with the arrow representations, where yellow is gravitational force. And then comparing that to the line model, we get two more comparable measurements for the magnitudes of electric force and gravitational force, which is more what we want. And why do the estimates differ, and which is more likely to be closer to the real value, and why? Estimates essentially differ because the line model we're taking into consideration multiple points along the line instead of just treating it as one point charge. As we could see before, the more points you have, the more accuracy you have. So we had 100 points with the line model with only one with the point charge. So the more points you had across the line, the more accurate you get. And you can see here that this is definitely the more accurate model because we're in a state of equilibrium. The forces should be pretty close to each other. Thank you.